Hello, sir. How are you?
Hello. Good, good. Thanks. How are you?
I'm doing well. I'm excited to talk today. We have like a loose plan of things that we want to talk about, and transaction delivery is kind of that topic, I guess.
Yeah, for sure. I think it's definitely something that's been kind of top of the mind, well, certainly on our side for the past couple of months, and with all the Solana congestion issues and all the changes to priority fees late last year. I think it'd be good to kind of just run through it, see what we found to have worked, what hasn't worked, potential pitfalls, and then the whole new meta that's opened up around all the other ways you can get transactions through now, rather than just on priority fees or kind of spamming the network as we used to.
Yeah, it's true. There's a bunch of like weird nuances to how transaction delivery works on Solana too, and like some of them aren't particularly obvious, which is maybe a whole separate thing. Like priority fees is a good example. Like they work kind of weird. Um, yeah, you want to go ahead and start and tell like what you guys have figured out at Fluxbeam that like what works well and what doesn't for that matter.
Mm. Yeah,
Lay the
no, for
land.
sure. Yeah, so I think like, and we started off kind of down this journey on kind of transaction delivery late November. We started noticing when blocks were filling up, we were just seeing these random dropped transactions. At the time, everyone was like, "Oh, it's not enough priority fee, or the blocks are full, or yada yada yada." We find that is now kind of actually a core issue with kind of the quick networking stack and how everything was stacked up when you send a transaction into a validator. Like, it's not immediately validated; it's put in a queue, and that queue has a limited amount of slots.
Hmm.
So if a very kind of incentivized actor wanted to use up all those slots, they could by simply just spamming the network and congesting it. And even if you did happen to land a transaction in those slots, it can get overwritten. So there was a lot of kind of intricacies that we started noticing on that validator RPC layer. And one of the big things we found was, and it's kind of, well, I wouldn't say contentious, but it's a kind of relatively new thing, is doing direct quick forwarding. So rather than utilizing your RPC provider, which sits on top of a validator, which then packages up into quick packets and then fires that across on Gossip, what you can actually do is you can go directly to the validator. Now you need to be careful because not all validators can be trusted, and you should only go to validators that aren't running kind of these private mempools. So we use mainly the GTO validators or kind of trusted top validators in order to do that, and we skip any sketchy, let's say, validators in that leader schedule. But what that allows you to do is bypass that whole RPC layer, especially for transaction delivery when it's hugely congested. That's just a whole other layer that you've got to contend with when it comes to trying to get your transaction through all of the noise. So that was kind of our initial big breakthrough. It was like, hey, well, let's go direct to quick. Obviously, it involves some server side infrastructure to kind of take that HTTP request and convert it over for the user. But we found that provided a huge amount of kind of improvement on the performance, mainly around kind of time to delivery. So it wasn't so much in terms of transaction inclusion, but the time of which it would take for you to see that transaction on chain was much, much quicker. So we'd see like one or two slots rather than the 10 slots delay
Hmm.
going through RPC. And then I think the other one was mainly on, I think for the most part, was on the Web3.js library, and or tuning your send transaction parameters essentially. I think min context slot has a lot kind of going for it and very widely underused at the moment. However, I think the biggest issue we've seen with developers is, or with teams kind of coming to us and saying, hey, transaction delivery is low, is there's this weird kind of sweet spot when you send a transaction that you might pass pre-flight checks, you might pass simulation checks, but when it gets to the validator, if you don't have the right min context slot set, what can actually happen, and this is why we see the blockhash not found all the time, is that
Yeah.
it's basically just going against like old data. It's stale data essentially if you don't put min context slot. Now you've got to be careful with it because not all validators can run at the head. So you want to use a reasonable kind of validation slot length. But by putting that in, it actually enforces the validator to wait until slot X, where your block hash is valid, rather than doing it one before and going, nah. And there was this weird kind of instance of whereby if that was happening, you would then just get these random phantom dropped transactions. So good block hash and using min context slot we found helped a lot, all going directly via quick. And then the other one was just the retry mechanism. Never put more than 0 retries on these RPC transactions, or what you end up doing is locking it at the validator layer. So say you then try to retry to send that multiple other times. If you've got that retry flag set, it'll actually just void your transaction whenever you send it to the validator, because it goes, no, I've got one
Oh,
already
really?
in
I didn't know
cache.
that.
And the annoying thing is they only retries every 2 seconds. So rather than retrying every block, which you would expect for a transaction kind of sequentially to be
Hmm.
retried, and when you look at kind of how leaders works and how kind of transaction delivery works, 2 seconds actually means you pass a leader slot. So if a leader's got a retry on it, it's not going to retry during its leader slot. It's just going to fire it over via gossip to the next leader. So you end up in basically your transaction is chasing, but it's too slow to ever catch up with this retry. So always set it to
Hmm.
0, do your own manual retries, and you see vastly improved transaction delivery, I think. Well, that was it from our side, but I know you've got some really interesting stuff
Interesting.
around blockhash.
Yeah, well, I mean, I want to dig in some of the things you said there, but yeah, for block caches specifically, I actually ended up I was trying to update the Solana documentation for it, so I like digging into the validator code base for like a couple of days trying to figure out like why people were getting the block hash not found error when like sometimes it doesn't make sense. It doesn't seem to make sense why you'd be getting it. And so like under the hood, how the block hash not found sort of works is effectively there's the recent block hash queue, and it's just a queue of 300 recent block hashes, but only the most recent 151 block hashes are actually considered valid and recent enough. So if your the specific block hash that you include within a transaction exceeds that 151, then it's no longer valid. You'll get block hash not found, which like it seems kind of weird because like it's still in the queue. It's just not recent enough. So like maybe a different error message would be more clear of like block hash is too old or something like that.
Hmm.
By the block hash not found. So a lot of people get tripped up on that. The Solana docs are updated to reflect that, and so that's one of the weird things with the block hash thing. But yeah, it's specifically within your commitment level. So when you're requesting, and then there's the other side of like how to get that recent block hash. Typically, like you're mentioning, most people will hit the RPC and say, "Give me the recent block hash," um, and depending on how close to the tip of the ledger that particular RPC is, they might actually think that it's a recent block hash, but their RPC node is struggling to keep up to the tip of the ledger, to the tip of the network. So they're actually giving you an already somewhat expired. They're giving you a ticking time bomb of a block hash, basically,
Hmm.
which is like really hard to tell, which is where the minimum slot context and the value comes in there, which helps quite a bit. Uh, so like if you're using an RPC node that is not performant enough and is not able to keep up with the network, or you have too much network latency, you'll start getting ticking time bombs of block hashes that are already like somewhat down the queue line.
No, that's fascinating. I mean, I think, yeah, error wise, we can do a lot better just in general on
Yeah.
Solana, because a lot of it makes no sense whatsoever. But it's interesting to see that kind of the data being fed back is kind of for the most part the cause of a lot of this. That,
Mm-hmm.
yeah, these RPCs or validators that are being used for whatever reason, not keeping up to the slot or having this weird acceptance of kind of 50, 100 block old data. I think there definitely needs to be an additional kind of check on the RPC side, because I think it trips a lot of people up, especially with balances and stuff like 5 second delay, which is like what, 30 blocks or 20 blocks. Like a user can have bought and sold crypto in that time, but their balance from an RPC provider's perspective may still be served as what they had
Yeah.
prior to both transactions. So yeah, I think especially operating kind of, I wouldn't say high performance, but if you need that actually up to date data, then having min context slot, we tend to use n-4. That gives the RPC a decent chance. At least you will still have to retry. N-50, I think, is the current accepted solution. It varies on RPC provider and performance and hardware, etc. But for the most part, we run kind of like a running queue of exactly kind of how you're saying. The block caches come through, or we monitor the slots, and then we just use, say, the most recent 50 block caches rather than relying on get recent block cache, which I think yeah, probably just returns more bad block hashes than it does good, or using recent
Probably.
get latest block hash, or maybe like a confirmed commitment, because we've also seen people using block hashes from processed, which then the fork gets dropped and then their block hash no longer exists, and you run into that
Yeah.
weird issue as well. So yeah, I think it'd be great to have more kind of insight and kind of developer docs on that whole block hash process. So it's such an important one for the transaction delivery cycle.
Yeah. Okay. I'll add it to the to do list. um, I want to circle back to one of the things you said earlier about forwarding the transactions directly using Quick on your server side. Can you talk about how you're actually doing that? Because I know that it's possible to do it at the RPC level. Like you can configure your RPC to immediately send to a voting validator, so that way you can get better inclusion. Because if a validator with stake, especially the more stake it has, the more likely you are to get inclusion. Because you're basically the RPC. If you configure the RPC, you can just forward it directly to that voting validator. So you're forwarding it to someone with more stake, or any stake for that matter. You have a better chance. Um, but how are you setting that up on like a server side that's not necessarily just a, you're not running your own custom validator? I don't think. Like, how are you setting that up?
Yeah, so we've got basically, well, we've got kind of two components. We have a component that basically tracks the leader, and that basically we run a whitelist of what leaders will accept to use, because a lot of sketchy things are going in the arbitrage mev world at the moment around private validators. So we stick to
Mm-hmm.
a whitelist set of known good actors in the ecosystem. You can track leader slots, and all the leader slots are published per epoch. So it gives you this really nice list of, hey, this guy's coming up in 50 slots, this guy's coming up in 100 slots. We also track when GTO validators are, because now the GTO's got, what, 80% of the network or something absolutely
Yeah,
crazy.
it's a lot.
They also have a lot of capacity. So validator tips, another kind of golden gem to get transactions through. If you imagine 80% of the entire capacity on Solana is used through Jito, like you're only accessing 20% of the available compute if you're not using Jito tips, because they have reserved capacity on each of their blocks. So utilizing Jito tips actually sometimes works out cheaper than adding a priority fee at the moment. Priority fees are sitting at
Interesting. Really?
about 0.02 Sol, I think, at the moment. Last time I checked our metrics, you can get Jito tips far cheaper than that. And if you're not too worried about delivery speed, Jito has a lovely retry mechanism that you can set up as well. And the
Hmm.
benefit of that is you're not charged for failed transactions. So there's, like, I mean, Jito, I'm a big fan of Jito, but there is a huge amount of kind of transaction delivery guarantees and benefits you can get through using their tips. I think it's a far better scheduler that they've got in that background building up these bundles. Obviously, you do have to be careful around kind of how much you use it, because you are rate limited quite heavily on their APIs. But for anything low to medium scale, I think it probably should be good to go just on the public endpoints. But we've got that from the leader schedule side, and then on the other side, we've just built out a simple you can do this in Rust. We built in Golang. We're a Golang shop over this side, so we've just got a simple HTTP server that mimics the RPC spec. So you can do a send transaction call exactly as you would via RPC. That comes to our node and is directly forwarded via Quick to those validators. Now, the game's changed in this
That's dope.
slightly. Yeah, it was very good until they found out, or the vast majority of people found out about it. Because the unfortunate thing about validators is they all have public ports, and this is for the most part what we were using prior to stake weighted QoS. So once people found out about how to route transactions via Quick a lot more efficiently, you only have a certain set amount of ports on these validators that are deemed public that you can access. So that very quickly, and I think at the moment it's just completely saturated. So that's where Stateway QoS came about. Is there's actually a priority set of connections available to each validator. So you're either their best friend and you get it kind
Yeah.
of set up for you, or can you go through a stake weighted QoS or a bandwidth markets implementation. And then there's a few kind of popping up now around this to serve this purpose. But what that allows you to do is, again, jump the queue and jump ahead of even more people. You jump ahead of all the public slots. So you're guaranteed inclusion above them if you've got a decent priority fee, or in Jito's case, if you pay a decent tip. So we have seen huge improvements in transaction delivery through that mechanism, purely because it's on a monetized network or a monetized lane. So you can almost look at it like a toll booth for like a motorway. But it's a lot cleaner. It's a lot simpler, a lot faster. Like slot time or slot delay is about 1 or 2 slots, whereas I think on public it's almost up to 10 slots at the moment.
Mm. Yeah, I mean, like by public, you mean like the public RPC endpoint that like comes baked in with the Web3.js, kind of like that one, or something
No,
else?
so all the validators publish a suite of quick ports.
Oh, okay,
So similar
gotcha.
to like how HTTP for your server, they've just got a whole range of them, and you can connect in. Essentially, like you can tap
Gotcha.
into
Yeah.
Gossip as well, but I think they've in the recent patch also patched that. So yeah, there was various ways of jumping the queue essentially on validators. I think for the most part has now been remediated, but stake weighted QoS I think for the most part is a far better solution than spamming and retrying the network.
Yeah. Yeah, the stick-weighted quality of service stuff is pretty interesting. I remember when the DevRel team, and I think it was Rex St. John at Anza, who's the one who like wrote the guide that I remember reading, and it talks about like how it all kind of works. I don't remember off the top of my head, but it was pretty interesting. The I'm curious, do you do any other sorts of optimizations within the transaction itself for like compute? Do you like manually set a compute your compute budget within it? Because like that, I've noticed that that's one of the things that a lot of people don't do, and that's actually one of like a super easy low lift that people can implement within their transactions to boost inclusion as well. And to like clarify it for people that don't know what that means, I guess, is when you are building your transaction, you can add in two of the compute unit or the compute budget instructions. There's the one that sets compute unit price and then compute budget limit. I don't think that's actually what it's called, but whatever it's called, the price, that's your priority fee. You provide a priority fee, which also doesn't quite work the way that people think it does. It's not like gas on Ethereum where it's not like you pay a higher priority fee and then you move to the front of the queue. It's more like you have a priority fee, so like you're in the middle ground of the queue. So adding like a dramatically higher priority fee doesn't actually move you closer to the top of the queue. It's pretty interesting. Um, but then the other side is the actual compute unit usage. So by default, Solana transactions set like I think it's 200K compute units per instruction, unless you manually define it and then you set it to whatever value you want. So one of the strategies is to, if you simulate the transaction simulation will return roughly how many compute units the transaction's expected to take. And then if you set that value within your actual transaction when you send it, then you're basically requesting less compute from the network. So it's easier to pack in your tinier transaction that is already only requesting a smaller value. So you're more likely to get included that way. But with a caveat of if you do the simulation kind of trick, which I actually think I heard about this from Star Atlas. If you do this simulation trick, don't use that exact value. Give like a 10% buffer on it, because if you use the exact value, like sometimes like things can change. You might go down a different code path in one of the programs, so the compute could fluctuate a little bit. So like add a 10% buffer, but that also is like another tactic that people can use in order to get better transactions.
Yeah, you got to be careful on signatures as well. Signatures are really expensive compute wise, and I think it
Yeah.
catches a lot of people out when they're trying to do this whole perfect compute level. Simulation simulates the program execution, not the entire thing. So I think it's about 5,000 compute units per signature if you add on, should get you kind of pretty much spot on to that overflow. Because I mean, these programs are deterministic, so you shouldn't see too much
Mhm.
difference. But that's where we've really seen people fall over. They're going, hey, it should be
Yeah.
43,000. The Explorer reports 43,000, but it fails. And it's like, yeah, you've got two signers, it's another 10,000 CU. And like, especially recently, since I forget how many minor patches we're at. I think it was 18.27 or 24. What they did is they slightly changed how priority fees work.
Yep.
And that really, really favors lower compute unit transactions now.
Absolutely.
Like it's night and day. If you've got 200K CU transaction, like good luck. If you put that down to 199,999, like you'll see your improvement go up by about 20%. But if you get that down even lower, and most of these programs, like you should be in the 50K CU range for
Yeah.
most things, unless you're doing an aggregator or something pretty complex. And yeah, we've seen that improve hugely. But we have seen kind of the well, we've seen that priority fees are now matching up better with inclusion since 1.18. I think it's still a bit of a kind of finger in the air whether you'll get in or not, but it does seem like there's a more reliable kind of comparison now. Like if you set slightly
Hmm.
higher, it does seem to make an impact, whereas before it was like, well, who knows what's going to happen? Who knows what goes on in the mind of the
Yeah.
validator when it gets your transaction?
Andrew Fitzgerald, that's who. He's the one that writes and maintains the scheduler code. Yeah, he basically tweaked the algorithm. It's a relatively simple equation of like how the priority fee and all these other fees get like calculated. He basically like they did a bunch of testing and they're like, oh wait a minute, if we just swap these values and swap them around a little bit, it actually favors the priority fee, or it favors less compute even better. So if you actually do this like requesting an accurate compute budget within your program or within your transaction, then you have a much better chance of actually getting included. And then plus, if you do all of these things that we're mentioning here, you've got a pretty darn good chance.
Oh yeah, 100%. And I think like the funny thing is everyone was calling for like doubling the block space and all of this two
Yeah.
months ago. And there's a graph I think it came out from one of the Anza guys, and it's like, no, use what you've got already, and it shows we probably got about a 50% overhead of unused compute across the cluster at the moment. So
Oh
people are
yeah.
requesting almost
There's so
double
much
what they
wasted
need.
usage.
Yeah, I got to get that number down. Like,
Yeah,
but
it's
I
crazy.
think
Well, because
it's going well.
it's sorry. This bothers me so much. Like it doesn't make sense to me because like I said, it defaults to 200K per instruction if you don't manually set one. So if you do some simple things, that's like a couple of token transfers, like an SPL token transfer is like a couple thousand CUs, but it's still like will default to 200,000. So you have this entire wasted amount. So you get these just empty blocks that have like nothing in them because people are just doing like simpler things. So you're just like wasting all this compute because the validators just can't pack those blocks as tight because it needs the buffer of all that extra usage that was requested, but then just completely not used because people aren't doing it. So I personally think we should set the default to like 50K per instruction. That way it's like more reasonable because that still covers most transactions that are like super simple transactions.
Yeah,
But
I don't see why it couldn't
triggers
be
me a little bit.
zero, and you have to set it. To be honest, I mean, like I get we need backwards compatibility, but I mean
Yeah, that's
it
probably
was a
why.
pretty rough change when they put it in back in the when it became an issue back in November. But like, yeah, I agree. It should be as minimal as possible. I think the new Web3.js has some cool stuff baked in around compute unit stuff as well. I think you can set up like a middleware layer in it, and it automatically does all of that for you. I haven't dug in too much on the Web3.js or the new version of it yet, but I've seen a fair few tweets, and it looks pretty good. Like
Oh yeah,
a lot
it
more
looks so good.
composable. So I can't wait to try it out.
Yeah, I need to take some time to actually like dig into it. I just finally figured out how to use Umi the other day, and I was like tinkering around with it, and it's gonna look pretty similar kind of concepts in there. Dramatically different than like the current Web3.js version 1.x. The 2.x, like the new one, we're at tech preview number 3 is live right now. Some significant changes in like how things work, and yeah, especially on the JavaScript size, like the bundle size is going to be so small.
Finally,
I
finally.
know the current one's like 100 kilobytes or something. It's like, why is this so big?
Oh, it's when you see what the wallets are injecting as well. I
Oh
cringe
yeah,
every time I run Lighthouse and you see like a 2 meg bundle come from one of the wallets. You're like, oh please, like
yup,
my load time
they're
doesn't need this.
they're big.
It's
Yeah, hopefully the new Web3.js with like wallet adapter things also makes that smaller too, which just less data transfer around the board, which is nice.
Yeah, I mean, I think that the developer ecosystem is definitely getting more and more mature by the day. I mean, some of the tooling that's come out over the past couple of months is just kind of insane. I mean, even on the validator side, there's so much going on. I wasn't kind of fully clued up, but there's like 3, 4 validators all building now. I don't know if you saw the Magic Block validator announcement,
Yeah,
Vthrow. Incredible. Like I was digging
yeah,
into
that
the
thing's
code
super
through
cool.
that. Wow, like such a cool idea, locking an account and having this 50 millisecond loop. Fantastic idea. So yeah, I can't wait to see if that's something that's been hiding away for 2, 3 months. I can't wait to see what else is coming out. And obviously we've got Fired Answer as well. That
Yeah.
unfortunately will just make all of our points we've just gone through absolutely moot, because I think that they're doing away with SQLOS and a few other things, and they've got the fully optimized network stack. So that's going to be an interesting one to get used to when that drops. I
Well,
don't know
so
if there's any update.
I don't think they are going to get rid of it though. Like that might be the end goal, but at least initially, like they inherently need to be backwards compatible with the Agave client because
Hmm.
like if you have these two different consensus softwares that are running, if they're not perfectly compatible, there's going to be so many issues there. So like
Interesting.
it's not gonna go away completely. Although the Fire Dancer team is, I'll say, kindly, strongly opinionated on some things there, which I think is like from the outside looking in, it's just like I've been on a couple of calls and it's just like they've got some strong opinions there. Like a lot of them are amazing and they're all clearly amazingly intelligent people and phenomenal fucking engineers. Oh my god, like Kevin Bowers optimized SHA-256, like
Ridiculous.
casually.
Ridiculous. Who does that? It's just mad.
Kevin fucking Bowers, that's who. Um, yeah, it's like yeah. So there's gonna have to be some amount of like compatibility there. But yeah, the Fireblocks validator thing that was super interesting. I remember talking with the founders at Mountain DAO, that
Hmm.
and Thurston, who's like the other like the third person there that's like working on it, and it's super cool. It's kind of like when they explained it to me, I kind of thought I was like, oh, so it's basically like a roll up, like a Solana roll up. Like they lock the account state. Although I don't know if you can like lock account state like that on Ethereum. I'm not super sure how like EVM kind of stuff works. But like they lock the account state on Solana mainnet, and then they're running basically a dedicated RPC node or a dedicated validator on their like private network that is like the roll up chain for just like the specific thing that you're trying to do. So like in their case, it's very gaming focused. They're a gaming company, and so they like lock the account state, and then they run everything at like 50 millisecond latency for every single like possible interaction, and then they Merkleize that, and then they post it back to mainnet, and they're like, great, the account state's unlocked, that like game session is over. And like they're explaining this in their like their entity component system kind of thing that they're working on too. And I was just like, holy crap. Finally, I'm bullish on Solana, like on chain gaming, finally. And like Solana's the only network that can do it even at the base layer.
Hmm.
But then it's like they're doing this. I'm just like, okay, on chain gaming, I can get behind it now.
Oh, 100%. I mean, yeah, I mean, like we've played around a fair amount with on-chain gaming over the past 2 years, and yeah, having that locked state and 50 milliseconds, like I thought I was spoiled with 400 milliseconds, but 50 milliseconds,
Can
oh, like
always be faster.
oh, it can, and it just gets better and better. I mean, like if someone doesn't build like a like an on-chain RuneScape at this point, like there's all the blocks there. So I think we need to see some kind of MMO coming out of fully on-chain kind of dynamics. Give the NFTs a bit of a refresh as well, kind of all running together. But I think like Solana's got such a good toolkit now for these gaming metaverses. I can't wait to see what's going to come out in this hack. I think it's either started already or it starts next week. The Magic Book I think is also running a hackathon,
Mm-hmm.
so it's going to like every time they do it, there's always cool games and stuff like that that comes out. So now with Mithril, hopefully someone builds something on that, and that's going to be super cool.
What's that? You said Mithril? Is that like another framework for game devs on chain?
That's the validator, the custom validator that they're running.
Oh, that's what they're calling it?
Yeah,
That's a pretty sweet name for it.
well,
I
that's
like
the
it.
code base, I think. I don't know if that's the official name yet. It might be a token 22, and we call it Mithril for a while, and then it
Oh
changes.
my god. John Chinkwe's talk at Breakpoint last year, like, oh, it's token 22 in 2024 to hopefully launch in 2023. It's just like, oh my god, John.
It
Uh,
got there. He did get it out. So I mean,
yeah,
only a year
extensions are
late,
dope.
or 2 years late.
Yeah,
Yeah,
I mean,
the
it's been
extensions are so
live for a
cool.
long time. They were just like working on the rest of the features and the rest of the functionality. But
Mm.
yeah, token extensions are super cool.
Yeah, I mean,
Maybe
when
we should do an
ZK,
episode on it. Maybe we
oh,
should
I'd
dive
love to.
into it because like Fluxbeam does like a lot of token extension stuff. Like I mean, that's like one of the things you guys do.
Mm.
Uh, yeah, token extensions are
Yeah,
dope.
oh yeah, I'd love to, and I think like especially with some of the stuff coming out, like once ZK is fully enabled and there's a bit more support,
Oh
which we
yeah.
are working with very heavily on kind of the transfer hooks to get transfer hook ecosystem up and running without as much stress as currently kind of involved with it all. like the sky's the limit. It's such a cool protocol, and just the, like, I mean, my favorite one at the moment is the on-chain metadata. Just being able
I
to have
love it.
all of that, it's just been a game changer, and it applies so well to so many use cases. Just having, I know it's a lot of data and it's perhaps wasteful, and we shouldn't be putting images in state, but it's so helpful from a developer perspective. Like, that's probably one of my favorite extensions by far from that protocol. But
Same.
I've seen they're building more. So I mean, like, we're going to get spoiled with even more extensions by the looks of it over the next couple of months. Because they were originally going to freeze the contract, but it looks like now it's going to be kind of an ongoing build. I'm not too sure if there's any updates around that.
Yeah, I don't know. The two that I'm like I know about is the group extension, the token group interface. That's going to go live at some point whenever it's the audit's done, and then zero knowledge, all the zero knowledge LGAML kind of shenanigans. Uh, that's going to go live at some point this year. Um, those are the only two that I'm aware of. But the token group stuff, you can like kind of use it now. Like the pointers are there, so you could do it and then retroactively, assign an asset to a group. But yeah, the token extension is so cool. The not even the non-transferable, the way that the non-transferable extension works compared to like typical soulbound NFTs or soulbound assets is like really cool.
Yeah,
Makes so much
yeah.
sense.
Oh, there's so much more kind of tooling and activities to play with on Token 22. Like, I mean, we just finished up our hackathon for on Token 22 to see what the community could come up with, and there's some really cool ideas that, like, you go through and you're like, damn, yeah, you can do that. It works with Token 22, and it's
Nice.
applicable on chain. There's some incredibly clever people thinking up this stuff. So yeah, like, need to build more tools and then see what else other crazy stuff we can get built. Because I mean, the past 6 months there's been so much new stuff. Like, we had our bear market and everyone's kind of quietly building, but wow, the product releases over the past couple of months have been crazy.
Yeah, they're so good. Plus with Breakpoint coming up around the corner, like there's going to be big announcements at Breakpoint. It's Breakpoint.
Oh, it's gonna be good. Yeah, that's gonna be a real fun one. Like, especially
Yeah.
after last year, that'll be wicked to catch up with everyone and put kind of names to faces. Because yeah, you meet all these people over the year on Twitter, and then it's good to meet up in person.
Oh yeah, for sure. Well, I think on that note, let's go ahead and wrap it.
Sounds good. Sounds good.
All right. Well, catch you later.
Bye.